Guys, so this is part 2 for our Unit 2 review. So now it's asking us to classify the polynomials by the degree and the term. So looking at the first one, we've got number 13. This is 6n, so it is a degree. We have an exponent of 1 here, even though it's not stated. So that means that this is a linear. Okay, so it is linear, that is our degree, and then the term would be monomial because there is one term. So it is a linear monomial. Okay, the next one, we look at the highest degree, which is right here, it's 2. So that means that this is a quadratic. And because there are 3 terms, so we've got 1, 2, 3 terms, that makes this a trinomial. All right, number 15, here again we've got an exponent of 4, so that tells us our degree, which is quartic. And because there is only one term here, there is no other term, it is going to be a quartic monomial. All right, and the last one here, we've got our highest exponent is 4. So this would again be quartic. And because there are 1, 2, 3, 4 terms, that would make this a polynomial. All right, the next one that we have, it is telling us to solve for A. So with literal equations, we are going to solve for A here. So we've got to isolate the A. We're going to draw our line straight down the equal sign. And then we are going to get A by itself by dividing by M on both sides. When I divide by M divided by M becomes 1, or it just cancels out. We are left with A on the left side of the equal sign, and then we have on the right side NP over M. And that's our final answer. That's it. That's all we have to do. There is no more simplifying that we can do because we can't combine any of the terms. The next one that we have is to solve for x. So again, I want to draw that line down the center of my equal sign. And to get x by itself, I've got to get x out from the bottom of this fraction. So I want to multiply this entire fraction by x. When I do that, x multiplying by x and dividing by x, those both eliminate. But what I do to one side, I have to do to the other. So on the left side of my equation, I'm left with c equals, and this is where I'm going to keep it in parentheses, d minus r in parentheses times our x. Now to get x by itself, we can go ahead and divide this entire right side by d minus r. By doing that, we are leaving x on the right side, and we're going to go ahead, what we do to one side, we have to do to the other, so d minus r. So when we divide, we are left with x equals c over d minus r. And that is my final answer for solving this literal equation. All right, the next one. Number 19, it tells us to solve for x. So we've got to get x on one side and all of the other variables on the other. So again, I want to draw that line down my equal sign to see where x is and where I need to move all of my other variables. So here I have x, and we've got to figure out what is y and c doing to that x. Well, we need to move the y over, and it is being added to x. So we are going to subtract y as well as subtracting c. You can subtract both of them at the same time. So when we subtract y and subtract c from both sides, we are left with x equals g minus y minus c. And if you were to rewrite this as g minus c minus y, that would be okay as well. All right, so either way that works. All right, next one, we are going to solve for a. So that is our end goal, is to solve for a. Here we're going to draw our line straight down the center of our equal sign, and then we are going to figure out, we have c plus a equals r minus d. So to get a by itself, we've got to get rid of this positive c. To undo a positive c, we are going to subtract c from both sides. When I do that, I am left with a equals r minus d, and then minus c at the very end. And that's it for that literal equation. All right, the last couple that we have for today is going to be finding the consecutive integer pairs. So for number 21, we have the sum of two consecutive integers is 45. So two consecutive integers, if we want to think of consecutive integers, that could be something like 2 and 3 or 19 and 20. Okay, but we've got to find the sum of two consecutive integers. So we have integer number 1. We don't know what integer number 1 is, so we're going to label that as x. Then we also have integer number 2. If it is the following integer from the first number, it would be x plus 1. So think about it. If we're trying to go from 19 to 20, we're just adding 1. So we are going to take the sum of these, so we are adding them together, and they are going to equal 45. So if we set this up as an equation, we have x plus my x plus 1, and it's going to be equaling 45. So then I'm going to combine my like terms, and I'm going to show that all right here. So I've got x plus x, which is 2x plus 1 equals 45. Well, now I've got a simple two-step equation. I'm going to subtract 1 from both sides, and that's going to give me 2x equals 44. Then I've got to get rid of the multiplication of 2, so I'm going to divide by 2 on both sides, and I'm going to squeeze that in here. It's going to be x equals 22. Well, that gives me my first integer right here. It tells me x equals 22, and we know that integer number 1 is x. To figure out the second integer, we have to plug that in to the x plus 1. So that would end up giving us our two answers are 22 and 23. And I'm sorry that it's kind of smushed in here. Hopefully that's easier to read. All right, so let's look at the next one. It says the sum of two consecutive integers is 27. So again, we have integer number 1. And we don't know what integer number 1 is, so anytime we don't know the value of something, we call it x. Then we have integer number 2. And this is going to be x plus 1 because it's the following number to x. We know that these are going to be added together because it tells us the sum. So these are being added together to equal 27. So if I write this as an equation, I would have x plus, because it tells me sum, x plus 1, and it's going to be equal to 27. So now I combine my like terms, and I get 2x plus 1 equals 27. And I'm going to show that up here. So I've got 2x plus 1 equals 27. I'm going to subtract 1 from both sides, giving me 2x equals 26. And then I divide by 2, so I get x equals 13. Okay, and I know I haven't showed all my steps. If you want me to, I can work those out later for you if you have any questions with how to solve a two-step equation. All right, so that tells me that x equals 13. So x equals 13. This is my integer number 1 right here, right? So this is integer number 1, but I've got to find my second integer, and I know that it's the consecutive number. So if I know that my first integer is 13, then my second integer would be 14. So 13 and 14 are my answers for number 22. Number 23 tells us that we have the sum of 2 even consecutive integers is 74. So if I'm thinking of even consecutive integers, that would be like 20 and 22. They're not right next to each other. They're the consecutive even numbers. So if integer number 1 is always represented by x, integer number 2, to get from the first even integer to the second even integer, it's now going to be x plus 2. Now, we still know that we are going to add these two numbers together, and it's going to equal 74. So if we write this as a mathematical equation, we've got x plus 2 equals 74. Now I'm going to combine my like terms, and I get 2x plus 2 equals 74. Now I can go ahead and solve for my first integer. So I'm going to subtract 2 from both sides, and now I have 2x equals 72, and then I have to divide by 2 on both sides, and so x is going to give me 36. So my first integer number 1 is 36. To find my second integer, I have to say 36 plus 2, which gives me 38. So these are my two final even consecutive integers for number 23. The last question that we have, it says the sum of 2 even consecutive integers is 134. So again, we are going to set this up exactly how we saw it in number 23. So we have integer number 1 is always going to be represented by x. We don't know what that integer is. Integer number 2, if it is the consecutive even integer, now it's going to be, instead of x plus 1 like we had in 21 and 22, it is going to be x plus 2 to get to the next even integer. We know that these are going to be added to equal 134. So now we can go ahead and set up our equation. So we have x plus 2, and that is going to be equal to 134. So now we're going to combine like terms. We have x plus x, which gives me 2x plus 2 equals 134. Now I subtract 2 from both sides. I get 2x equals 132. Then I divide by 2 on both sides. So then I get x equals 66. So my first integer, my first even integer is 66. And my second consecutive even integer, so if I'm plugging in 66 for x here, 66 plus 2 gives me 68. So my final two consecutive even integers that add up to be a sum of 134 are 66 and 68. And that's it for today, guys. So now you have the opportunity to retake your Unit 2 test, which is going to be on Delta Math. You have to show your teacher your work for each one of these problems, which shouldn't be difficult because we just went over all of them. Get that signed off, and then you will be able to retake your Unit 2 test. If you have If you are satisfied with your Unit 2 test grade right now, then you will be working on your Unit 2 extra practice. There are 2 different assignments that are in its learning. Have a good rest of your day, guys.